Hello, geometry. I have exactly 8% left on this iPad to try to prove angles congruent, or help you guys learn to prove angles congruent. So let's get started. All right, what do we know so far? And these are the things we're going to use today. There are many things we've learned so far. These are the ones we're going to use today. If angles form a linear pair, abbreviated LP, and that's a standard abbreviation, you may use it, then they are supplementary. So if angles form a linear pair, then they are supplementary. Either of these abbreviations for supplementary are also fine. All right angles are congruent. Abbreviated, all right angles are congruent. We haven't really used that so far. We've introduced it, but it's intuitive, right? All right angles by definition are 90 degrees, and therefore if they have the same measure, they are congruent. So angles complementary to the same angle or to congruent angles are congruent. We kind of talked about this in class one day, but let's talk about it again. We have three angles here, right? And we can see, here's our little, I tried to draw it so that they wouldn't overlap and it would be easier to see, but 1 and 2, those are complementary, right? Because they add up to 90 degrees. But look at this. 2 and 3, 2 and 3 are also complementary because they add up to 90 degrees. Well, what's the common link? We have angle 2 appears in both. By the reflexive property, angle 2, I have 5% left now. Angle 2 is congruent to angle 2. If 1 is complementary to 2 and 3 is complementary to 2, then these two have to be congruent as well, right? Come on, back to black. So those two are congruent. The definition of a straight angle is something we know. A figure formed by two opposite rays. This is just this, right? We have a point here. We have arrows there. Let's call that B. Call that Z. Zab. That's a straight angle. And straight angles are 180 degrees. Angles supplementary to the same angle or to congruent angles are congruent. That's very similar to this guy up here, and I encourage you to draw a diagram to convince yourself that this is true. Okay. If two angles are congruent and supplementary, then they are right angles. We haven't talked about that one yet, but we're just talking about, let's draw some decent lines. How about, no guarantees. There we go. Two angles are congruent and they are supplementary, then they are right angles. Let's not do that. That's this mess, right? Perpendicular lines intersect to form four right angles. Again, we probably don't need much to convince ourselves that this is true, but let's do it anyway. Let's draw. Oh, I'm sorry, you guys. I keep hitting my but I have to rest my hand on this. Okay, so there are two lines, roughly perpendicular. Let's call them perpendicular. We're going to say these are perpendicular. For the sake of this argument, we're going to call these all perpendicular. And something new, vertical angles, abbreviated vert-angs, right, are congruent. And what are vertical angles again? Anybody remember? Now would be a good time to check your notes, because we need to understand this as we move forward. And it's perfectly acceptable and even encouraged that you refer to your notes in class and during these videos. All right, let's look at a proof then. Let's prove that vertical angles are congruent. This is a theorem you'll use very often. Here is the proof that it is in fact true. So we're given angle 1 and angle 2 are vertical angles. Let's pick a color. Angle 1 and angle 3 are vertical angles. And we want to prove what I just marked on the drawing, that they are congruent. Well, let's start with the given statement. Always start a two-column proof or any proof with what you're given. And in this case, we're given angle 1 and angle 3 are vertical angles. Okay. Well, what's next? How do we get from vertical angles to congruency? How do we get from we know they have a certain relationship to they are of equal measure? Sometimes it's helpful to skip to the last step and see what step you need right before the last step to get there. And this is a fairly short proof. I haven't numbered that statement because I don't know how many statements I'm going to end up with. But I don't see, oh my goodness, I don't see how we can get from the last step. What do you guys think? Maybe we'll go in order. What do we get from angles 1 and angle 2 being vertical? Well, we know that not much there either. What else can we tell from the drawing? Let's do that. How about angle 1 and angle 2 form a linear pair? And angle 2 and angle 3 form a linear pair. And I can see right away I'm going to run out of room. So let's fix that. So how do I know that those are linear paired? I mean, from the definition of linear pair, right? They form straight angles. They're supplementary. And a linear pair is something we can tell from a drawing. We don't need to be told that it's a linear pair. We can tell from a drawing. All right, so what's my next step? What does that get me? Well, now we know that angles 1 and 2 are supplementary. Sup. And angles 2 and angle 3 are supplementary. And how do we know that? Well, we have a theorem that tells us that if two angles form a linear pair, then they are supplementary. Okay. Well, didn't we just see something up here? I want to say right about, here. What we can do if angles are complementary to the same angle. And we can do the same thing with supplementary angles, right? If two angles are supplementary to the same angle, then they are congruent. So we can jump to the last step here and say angle 1 is congruent to angle 3 because angles supplementary to the same angle are congruent. And we know that these are we know that they are supplementary to the same angle because look at what we have right here. They are both supplementary to angle 2, which means angle 1 and angle 3 are congruent. And that's our proof of the vertical angles theorem. And you'll use the vertical angles theorem a lot. And the nice thing about the vertical angle theorem is that it's easy to remember. It's the one thing everybody seems to get. The hard part of using the vertical angles theorem is sometimes telling from a drawing which angles are actually vertical. And we're going to do an example like that in a second. But right now, let's use the vertical angles theorem to do some algebra. So we want to find the measure of angle 7 and measure of angle 8. They are vertical angles, and we're given an algebraic expression for the measure of angle 7 and an algebraic expression for the measure of angle 8. So let's do this, but I want to justify our proof, or our everything we do. Just like we did in Algebra 1, I want to justify each step. Even though it's algebra, it's not technically a two-column proof, I still want to justify each step, because we will be combining theorems and properties of equality in our proofs in the very near future. So we know that angle 7 and angle 8 are vertical angles. That's given. Which means their measures are congruent, and that is according to the vertical angles theorem, right? Let's use blue. And this is just substitution in the next step. Substitution, P-O-E. Now, let's write it out. Because if we start abbreviating substitution, that the wheels kind of come off, because it looks an awful lot like subtraction sometimes. Okay, so let's say substitution. And then to get from this step to this step, what did we do? That's just the addition. And call that addition. P-O-E. You can also call that combining like terms. I'm totally fine with that. They're mostly interchangeable. And we would do the same thing here. Let's say addition, P-O-E. Then we divide, right? Division, P-O-E, property of equality. Just like Algebra 1. And then from there, we can say that measure of angle 7 equals 3 times 10, because you're not done. We found x, but what we're asking for up here is the measure of angle 7 and measure of angle 8. So we get 3 times 10 plus 6. The measure of angle 7 is 36 degrees, and the measure of angle 8 is and that's as expected, because they are in fact vertical angles, and if they didn't end up congruent, that's supposed to be a 36. I know. Okay, that's not much better. But if they didn't end up with algebraically to have the same measure, then it would mean that we did something wrong. Okay, last one, best one. Wait, is this the last? No, we have 2 more. See, I always lie about that, don't I? Okay, so now we're going to do a 2-column proof. And let's not do that. Come on. Given that angle 1 and angle 2 in the drawing form a linear pair, we want to prove that they're supplementary. All right, so how are we going to do that? What would we do first? Well, of course, we always start with the givens. Always start with your given statements. In this case, I mean, all of your given statements, if it's appropriate. And in this case, we just have 1. So I've written our given right there. And I have what we're trying to prove down here. I need to get from point A to point B some kind of way. Well, let's think about this. What else do we know? We're given in a statement that angle 1 and angle 2 form a linear pair. What can we use that for that might lead us to 1 and 2 are supplementary? Well, we need to somehow prove that angle 1 and angle 2 add up to 180 degrees, how about this? How about if we said, and notice I want to point something out right quick. Notice in this two-column proof I have A, B. Up here I had no numbers in the algebraic proof. And up here we had statements numbered 1, 2, match them that way. You will see proofs on tests in your book, in life, that are written in all kinds of different ways. So I just want you to know that there's no true one way to write a two-column proof as far as the numbering goes. And you may choose whatever you like. Okay, so let's say statement B then. Here's what I like for statement B. I like, let's keep the picture in view. What is happening? There we go. For statement B, I like yx they are opposite rays. How does that help us? And that's just by the definition of opposite rays. Well, once we know we've established or introduced the idea that they are opposite rays, once we've introduced that into evidence in our proof, we can use it to say that the measure of angle XYZ equals 180 degrees. Because that's a straight angle, right? XYZ, here's X, Y, Z. That's a straight angle, and we just said a few minutes ago that straight angle is 180 degrees. Or, I'm sorry, is formed by opposite rays. They are, in fact, 180 degrees. And that's by the definition of straight angle. All right, now what? Well, the measure of angle XYZ happens to equal the measure of angle 1 plus the measure of angle 2. And how do we know that? Do you remember the angle addition property? That's what that is. All right, I need to somehow erase this without also erasing my line. All right, is that enough to get us to what we're trying to prove, that angles 1 and angle 2 are supplementary? Believe it or not, it's not. It seems like we should be able to just say, okay, well, up here in step C, XYZ is 180 degrees. And if the measure of angle XYZ equals the measure of angle 1 and measure of angle 2, boom, we're done. But not in geometry. We haven't actually technically stated that these two add up to 180 degrees. So we have to do that, which is kind of a bummer, but let's do it. Measure of angle 1 plus measure of angle 2 equals 180 degrees. And that's just, believe it or not, the substitution property. Why is that the substitution property? Well, up here we said measure of angle XYZ equals 180 degrees. Down here we said measure of angle XYZ equals measure of angle 1 plus a measure of angle 2. So we have that as our algebraic substitution, right? So now we're just going to substitute this into this equation. We're going to substitute measure of angle 1 plus measure of angle 2 into the statement we made in step C. That's substitution. Now we get to say that angles 1 and 2 are supplementary. And that's just by the definition of supplementary angles. Okay, last one, best one. And this is what I'm talking about with vertical angles. So what we want to do, we have a whole lot of vertical angles in this drawing. And some of the drawings you're going to see in the book and on quizzes and tests are going to be even harder to figure out which angles are vertical. This is actually a fairly easy drawing. It just has a lot of vertical angle pairs. So let's figure out which ones those are. Let's use blue again. I think we can see that angle 8 and angle 11 are vertical, right? What about angle 9 and angle 12? And how about, what color? Yellow. Angle 7 and angle 10, right? So we have to just be able to find the shared sides in the opposite rays and to truly tell which angles are supplementary. I'm going to take those colors out. If I can. There we go. Just so we have the original drawing. So we have measure of angle 7 equals the measure of, equals x plus 20. But we don't have anything for angle 10, which is its vertical angle. So what about angle 8? Well, that's x plus 40. We don't have anything for its vertical angle. We have measure of angle 9 equals x plus 30. So we have all of these. Oh, hey, look at that. Don't they add up to a straight angle? They really, really do. So let's do that. Let's say x plus 20 plus x plus 40 plus x plus 30 equals 180. And we get 3x plus 90 equals 180. 3x equals 90 and x equals 30. Okay, so we have x. We still don't have angles 7, 8, and 9, but we can figure those out, right? Measure of angle 7 equals x plus 20. That equals 50 degrees. Measure of angle 8 equals x plus 40. That's 70 degrees. Measure of angle 9 equals x plus 30, and that's 60 degrees. And that had better, these numbers had better add up to 180. Let's see, 60 plus 70 is 130 plus 50 degrees is 180. Boom, done. However, the question asks us to find each angle. Well, now you can use your vertical angle theorem, right? Because look at this. Angle 9 is vertical to angle 12. Why am I not writing? There we go. So we can just say angle 12 then equals 60 degrees by the vertical angle theorem. And I want you to find 10 and 11 on your own. And I will check your notes. And that's it for this one. I know it's a long one, but it's a lot. And we'll be doing some practice problems